In math this year, we've been focusing on developing mathematical habits of mind through targeted problem solving. This week, we introduced the button problem in order to encourage students to consider how a systematic approach might help them recognize patterns or connections that could lead to generalizations as they work toward a solution.
Alright, so I did this in rows as well, and I figured out that in each row there will be 2 1s, 2 2s, and 2 3s.
So I think for every pattern there's a partner pattern, which is just that pattern in reverse.
I used Jasmine's conjecture to work on my. I came up with the number of possibilities is a multiple of the number of buttons.
For 3 buttons, I noticed that since the max is 6, I tried to justify that by saying there's 3 different buttons you can start with, so that, and then after that there's 2 different buttons you can go to, so that'd be 3 times 2. And so I thought maybe that will work for the other ones too. So I tried it with the 4 buttons, and I got 12, which is half of what 4 buttons is.
I just noticed that 6, which is the number of combinations for 3, times 4 is 24, which is the number of combinations for 4, right?
Right.
And then I'm figuring if 24 times 5 would be the number of combinations for 5.
So I started off finding all the combinations when the first button was number 1 and number 1 was the top, and then I figured if I start with the middle 1 and middle 2, I would get the same amount, so I just multiplied this by 4 and got 24.
At first I was just starting to write out possible combinations, so I thought I'd start with the first 2 locked solid.
Yep.
And I just did the most basic, 1 and 2.
Okay.
And I managed to come up with 6 different possibilities by rearranging these all in different orders. Then I realized I could repeat all of this, all of these patterns, by merely interchanging this number, and there were 4 possibilities for that slot, so 4 times 6, 24.
Okay.
And then I realized with 24 possibilities for this position, I realized I could then change that even farther by multiplying it by 5, and then the resulting answer was 120, which I have come to believe as the maximum amount for 5 buttons.
N2 times N1 times 3, because N1 is the amount of buttons, N2 is the previous answer, and then times 3 because we had to use the procedure for 4, 5, and 6, but not 3 because we didn't have 2 buttons. The lowest was 3.
You take the amount of buttons and multiply it by the previous number of possibilities, and then that comes from the solution of the previous, and you can work it down to 3. So just knowing 3, and you could find out how many solutions there are to 100.
It's factorial, so it's like 1 times 2 times 3 times 4 times 5, blah blah blah, until you hit the number that hit N.
This is the number of buttons, this is the number of possibilities.
So if the number of buttons is 7, what does 7 factorial mean?
7 factorial would be
1 times 2 times 3 times 4 times 5 times 6 times 7.
If you just said what you just said, which I can't remember because it was confusing, to someone who hadn't figured out the pattern that I figured out and other people figured out too, they would be confused.